dear students, good morning. Welcome back to the topic of dark reaction in the photosynthesis concept. So in the dark reaction, nothing but carbon fixation or C3 cycle. There was 3 steps are there, already we learned, and this is the part 2. In that you are going to learn so many calculation part. Before that, let me recap the thing which happened in the last. So dark reaction consists of 3 steps. Step 1 is carboxylation. Step 2 is reduction, and step 3 is regeneration. This is what we learned in the last class by the help of some cyclic phenomenon. In step 1, generally what happened is RUBP, that is ribulose bisphosphate, which is a 5 carbon component. RUBP accepts carbon dioxide, ratio is 1:1, and becomes PGA, phosphoglyceric acid. Here I am not mentioning the molecules ratio. Why? Because there, for understanding, to get the one glucose molecule we need 3, so that cycle becomes twice. So this RUBP, ribulose bisphosphate, accepts carbon dioxide. So RUBP is 5 carbon component, carbon dioxide is 1 carbon component, right? So that if one RUBP accepts 1 carbon dioxide, then how many molecules of PGA forms? PGA is 3 carbon, right? Then 5 carbon plus 1 carbon, 6 carbons. But this is 3 carbon, so 2 molecules will form. 2 molecules of PGA forms. This is what called carboxylation. In this carboxylation, the very important enzyme is involved here, that is called Rubisco. What is Rubisco? Ribulose bisphosphate, carboxylase and oxygenase. So it has a dual nature, and it is the most abundant protein in the world. Nothing but enzymes are derived from protein. This enzyme action takes place so that carbon is accepted by carbon acceptor. I repeat here, RUBP is carbon acceptor. Clear? Then what is the product? Phosphoglyceric acid. In the dark reaction, in the first step, very first product that is stable is called PGA, phosphoglyceric acid, which is 3 carbon. That is the reason dark reaction is also called C3 cycle. Now in step 2, what is happening? This PGA, phosphoglyceric acid, which is 3 carbon component, becomes phosphoglycer aldehyde. Phosphoglycer aldehyde is also 3 carbon component, isn't it? So PGA is 3 carbon component, PGAL is also 3 component, but it is acid, it is aldehyde. Acid become aldehyde. Here 2 ATPs are become 2 ADPs. It seems 2 ATPs are used. At the same time, 2 NADPH2s are also used and become 2 NADP plus. Don't confuse. In the last session, I used the number 6. Why? Because I took carbon number is 3, but here carbon number is 1. 1 RUBP means 1 molecule of RUBP accepts 1 carbon dioxide. Means 5 carbon molecule RUBP with 1 carbon of carbon dioxide merged, fused and formed 3 carbon, 2 molecules of PGA. So total 6. 2 into 3 carbon, 6 carbons. So PGA 2 PGA molecules required, 2 ATP. Then, so total, and 2 NADPH2. No confusion. 2 PGA molecules required, 2 ATP. 2 PGA molecules required, 2 NADH2. Then 6 required, 6. That's it. Now, in step 3, what is happening? In step 3, this PGAL phosphoglyceraldehyde, which is how many carbon component? 3 carbon component. It will become a 5 carbon component, that is RUBP. This is it. So, end product is again used for first step. That's why it is cyclose. So, it is a 3 carbon, but it is 5 carbon. Meanwhile, what is happening? It is regenerating, of course. That is why this step is called regeneration. Regeneration of starting substance. What is that? RUBP. Then what is this step is called? This step is called reduction. During reduction, acid become aldehyde. That aldehyde is regenerated into RUBP. That 5 carbon is RUBP. RUBP means what? Ribulose bisphosphate. So, that time what is happening? One phosphoglyceric acid is coming. Glyceric acid is 3 carbon. Right. So, means if you take here 6, then 1 comes out, that is a 3 carbon, you got that concept. This 3-PGA future is glucose. Means it is the triose. Another triose comes. If we take the 3 carbon, if you take the 2 carbon, reaction should be 3. If you take the 3 carbon, reaction should be 2. So now PGA becomes glucose molecule. What is glucose? Glucose is carbohydrate. So the theme of the concept in the dot reaction is carbon present in the carbon dioxide should be fixed in glucose. Glucose formula C6H12O6. So how many ATPs are used in entire process of dark reaction is the concept. Now we are connecting. In carboxylation, no ATP used. Isn't it? There was no ATP. One enzyme, that is a Rubisco. Carbon has been accepted by RUBP. In second step, in PGA becomes a PGAL, that is a reduction step. How many ATPs are required? Simply for the glucose molecule, we just take that these are the 6 PGA, then 6 ATPs are required. 6 ATPs are required. And 6 NADPH2s are required. My question, where does they are coming from? Light reaction. If light reaction happens from lumen to stroma, when protons are coming back in the chemoosmotic hypothesis concept, you have learned already. That time ATPs are and NADPH2s are synthesizing. In case of NADPH2, that should be non-cyclic photophosphorylation. In case of ATP synthesized, that may be both cyclic and non-cyclic photophosphorylation. Of course, in cyclic photophosphorylation, more ATPs are synthesized. Reason? 2 places energy will be released in the long electron transport chain of the cyclic. It's okay. But here there is no ATP synthesized. Here 6 ATPs are synthesized. Now let us see the third step. In third step, what happened? Aldehyde become sugar. So 5 carbon sugar. This is molecule conversion from PGAL to RUBP required. How many ATPs? In the last step, already seen that 3 ATPs. Here 3 ATPs were used, but no NADPH. So in all together, from all these 3, how many ATPs are used? Here nil, here 6, here 3, total 9. So 9 ATPs are used for 3 carbon component. But to form glucose molecule, how many ATPs are required? Glucose is 6 carbon. It is triose. Glucose is hexose. So 2 trioses, 3C plus 3C is equal to 6C. For 1 3C evolve, we need 9 ATP molecules. Isn't it? For 6 carbon into 2. That is 18 ATP required. To form one glucose molecule in the dark reaction or C3 cycle or carbon fixation, how many ATPs are required is question. Answer is 18 ATP. I repeat, how come this 18 ATP? Okay? Or how these 18 ATP are involved in the light reaction to produce glucose molecule? Means in the phosphorylation there was no ATPs are involved as enzyme plays major role. But in reduction, number of PGA is equal to number of ATP. If you take 2 PGA, 2 ATP. If you take 6 PGA, 6 ATP. So that in concept we took means this cycle should be run twice. For once 6 ATP. But twice means this reaction takes place second time also. So 6 plus 6, 12 ATP. Whereas here 3 ATP. This step is also twice happens. So that 3 ATP plus 3 ATP, 6. So here 12 plus here 6. 12 plus 6, 18 ATP. So otherwise 9 into 2, 18 ATP is what required. So number of ATPs required for formation of one glucose molecule is 18. There is no doubt in that. Now second question is, how many NADPH2s are required to form one glucose molecule in the direct reaction? If you observe in the first step, that is carboxylation, there was no NADPH2 is involved. Major one in the first step is Rubisco enzyme. In presence of carbon dioxide, Rubisco full form is ribulose bisphosphate carboxylase or oxygenase. So that enzyme have a dual nature. In the presence of carbon dioxide, carboxylase like it will act. In the presence of oxygen, oxygenase like it will act. For clarity I will tell you. Suppose carbon dioxide merely present, then Rubisco in that C will be act. Ribulose bisphosphate carboxylase, that's it. In case oxygen is there, then what is the name of that enzyme? Ribulose bisphosphate oxygenase, not carboxylase. As both the proformas, both the phenomenons, it is being conducting, that's what is called Rubisco. Now, so NADPH2 doesn't involve here. In step 2, NADPH2 is required for the reduction process. Because of NADH2 only, that H is coming. The source of that. Hydrogen is adding means reduction. Hydrogen is adding to acid so that acid become aldehyde. So in the reduction process, 6 NADPH2s are required. Here also, if you take 2 PGA, there 2 NADPH2. In the textbook, they mentioned 2. So that you can follow with the 2. But in concept, I mentioned 6. So that how many molecules of 6 phosphoglyceric acid is formed? 6. But here we have to take that 6, then 6 NADPH2. For 1 triose. For hexose, nothing but 6 carbon multiply into 2. So that 12 NADPH2s are required for glucose. 6 NADPH2 is required for triose. So how many? 12 NADPH2s are required. How many ATPs are required? 18 ATPs are required. 18 ATPs and 12 NADPH2s are required to form one glucose molecule. In questions, by the photosynthesis there was a 10 glucose molecules are produced. Then how many ATPs and NADPH2s are required? So then answer is 1 glucose is equal to 18 ATP. 10 glucose is equal to 18 into 10. So that 180 ATP, and in the 10 glucose molecules, 1 glucose molecule required 12. 10 glucose molecules means 120. So 120 NADPH2s are required according to the given data in the question. That is how we have to answer. And all this process takes place in mesophyll.
Calvin cycle. The process of Calvin cycle takes place inside the stroma of chlorophyll. It is also known as light-independent phase. The solar energy is composed of various colors. The Calvin cycle consists of a series of reactions that reduce carbon dioxide to produce the carbohydrate glyceraldehydes 3-phosphate. The cycle consists of 3 steps: carbon fixation, reduction, and regeneration. The first step is carbon fixation. In this step, carbon dioxide is attached to ribulose 1,5-biphosphate, resulting in a 6-carbon molecule that splits into 2 3-carbon molecules. The second step is sequence of reactions using electrons from NADPH and some of the ATP to reduce carbon dioxide. In the third step, ribulose 1,5-biphosphate is regenerated. For every steps of the cycle, 5 molecules of glyceraldehydes 3-phosphate are used to reform 3 molecules of ribulose 1,5-biphosphate. The remaining glyceraldehyde 3-phosphate is then used to make glucose, fatty acids, or glycerol. It takes 2 molecules of glyceraldehydes 3-phosphate to make 1 molecule of glucose phosphate. Thus, the Calvin cycle has to run 6 times to produce 1 molecule of glucose. Glucose phosphate is also the starting molecule for the synthesis of starch and cellulose.
Clear? In the next class, I will explain another carbon fixation that is very rare in the plants, not in all plants. 99% of plants in the world are performing the dark cycle, that is the C3 cycle, to prepare glucose. But some plants, those are adaptively living, means they are living in the desert, they are living in the xerophytic conditions, okay, that are temperature conditions. In that, light and carbon dioxide ratios are very various. That time plant's behavior is different. Instead of C3 cycle, C4 cycle will be initiated. What is C4 cycle? What kind of products will be formed? And how many ATPs and NADPs are required for that? We will learn in the next class. That is C4 cycle. First concentrate on the C3 cycle. Today's assignment, you will have a 10 to 15 questions about C3 cycle, last concept and today concept. I hope you enjoyed that lecture. All the best. Thank you.